Thank you for joining. My name is Maxim Fativ. I'm Principal Engineer at Amazon Web Services, and today I'm going to talk about AWS Flow Framework, which is framework for building distributed fault-tolerant applications, which uses simple workflow service as its backend. When I was preparing this presentation, initially I came up with a pretty large number of slides describing every possible feature of the Flow framework, but then I thought that it would be just much nicer to show you example and for you to get taste of what framework is, and then later you can we can have another webinar, or you can just go for documentation to look for particular features of the framework. It's pretty common case when you have an application which works. For example, you have some application which is or a piece of code which is invoked when the user presses a submit button on the website, or which runs from cron job or from command line. And very frequently this application outgrows itself, and you add more features, and at some point you feel that it's taking too much time, or for example user cannot wait that much on the website, or some server crashes, so you decide to make this piece of code fault-tolerant and scalable. And at this point, the problem is that you practically need to start from scratch, because yes, you have your business logic written as code, but as soon as you try to modify it and give it fault distributed and make it fault-tolerant, you practically need to redesign it. And the resulting code usually looks very, very different from the initial implementation. What I want to show you is that if you use simple workflow and flow framework, you actually can keep most of your application intact and just focus on your business logic, while the framework and the service take care of plumbing for you. I'll just jump into the code and show you the example. We'll start from a simple synchronous program in the domain which everybody is familiar with. It's Hello World domain, application domain. And I made the standard Hello World just a little bit more complicated, breaking it into 3 operations. We have get name operation, get greeting operation, and say operation. And following standard Java practices, we define those operations through interface, and we have the method which uses those operations to implement our high-level business logic. If you try to map it to the simple workflow concepts, we would call those operations activities, because they are atomic units of work which perform some useful function, but they really don't depend on other units directly, on other operations. And also we have, they're kind of independent from each other. For example, they can be used in different contexts, because say, for example, prints anything, and not necessarily hello world, it can be used in other cases. And then our greet method would be what in simple workflow we call orchestration logic, because it uses those operations to provide some high-level business use case. Let's execute this code, and it prints hello world as we expected. Let's say we want to make this application distributed, and it's not trivial task, because we have interface and implementation of operations, and we call those operations, but how would you make this distributed? Because yes, we can use, for example, Java RMI, but the invocation of those operations still will be synchronous, and it won't really make our applications more fault-tolerant, probably would make it less fault-tolerant. So let's convert it to the simple workflow using Flow Framework. I'll just make a copy of the whole package. To start with, let's call it workflow. And let's start from operations. As I already mentioned, operations in the simple workflow terminology are called activities. So the way you actually say that these operations are activities, you just use conveniently named annotation, activities annotation. And this annotation requires you to specify version. The reason is that as soon as we say that these operations are activities, they can be run on multiple boxes, and we are already talking about distributed system. And when we have a distributed system, you need to think about how you are going to upgrade it while running it. So versioning is the good way to deal with those problems, and that's why version is required. Other parameters are specified through activity registration options annotation, and two required parameters are timeouts. First timeout, start to close timeout, is the timeout which practically says how long your activity can execute. So if you expect activity to not take more than, for example, a minute, you specify this timeout, and then if it fails for any reason and doesn't your process, if it fails, it will just report the failure. But for example, if process crashes, then after a minute, the workflow code will be notified about the failure. So let's say in our case, we don't expect the activity to take more than 10 seconds. And second timeout is scheduled to start timeout. It's a timeout how long the activity, a task can take from its from request creation, when we call schedule activity operation, down to being picked up by being started, which is when the worker picks it up. So it's for how long it can be queued inside of simple workflow. And the reason for that, for example, worker can be not just running or maybe not being able to keep up with activities which are created. And you have control for how long you are willing to wait for activity to be queued up and not being processed. So let's say we are willing to wait 5 minutes. So just putting these two annotations, we actually converted these operations to activities which can be executed using simple workflow. Let's look into the implementation. Actually, we don't need to do anything about implementation. It just can be as it is. There are other ways to have this implementation. One of them would be not even using Java. You still can have interface defined to be able to call those activities, but implementation can be in any other language, assuming that we agree on the serialization format, in fact, wire protocol. And also, you can have activity which is kind of not linked to the method body completely. You can practically initiate activity from this method, but then complete it from a different process, for example. But I'm not going to spend much time today on that. We just don't have enough time to just go into those features. So now let's convert the code of which uses the activities, the operations which we converted to activities. Let's start from the actual interface. So we have to do things similar to what we've done with activities interface. We have to annotate this interface with workflow. And workflow corresponds to what we call decider process in a simple workflow service documentation. Similar to activities, we have to specify registration options. And the only required registration option is execution start to close timeout sense, which is timeout of the whole workflow execution. For example, if you create workflow execution and don't have any workers and decider or activity workers running at all, it will time out after that time. And or you just cannot complete workflow by the time it will be automatically terminated by the system. So let's say we are willing to wait up to 5 minutes for this workflow to complete. Also, we have to annotate the entry point of the workflow, which is practically where the workflow main execution logic is. And the way we mark this entry point is by execute annotation. And here we specify the version. There can be other types of methods like signal or get state. I'm not going to spend much time on them. But the point is that all activities, in activities interface, all methods define activities, but in workflow interface, there are different types of methods, and most important one is execute. So we annotated our interface, but we have to also convert the code of the workflow. You see it compiles, so technically we can execute that, but it actually is not going to call into our remote activities. It just will go against the shape this activities implementation locally and execute. It's not what we want. If you want to invoke activities through simple workflow, we have to actually start using activities client. And the difference between client and the original activities interface is that it returns not the string or whatever type you specify in the activity signature, but it actually returns promise to that type. And also it takes this type as a parameter. So for example, getGreeting accepts promise to string. I'll spend more time later describing what promise is exactly, but the basic idea is that it's a result of asynchronous, it's placeholder for the result of asynchronous invocation. As the activities can take a predictable amount of time, this operation getNameCall returns immediately and returns us the promise object. And the same happens about getGreeting, returns greeting and returns it immediately. Note that actual operation happens only when all parameters of that type of promise type are ready. So for example, getGreeting activity will run only after name is ready, and say activity will run only when greeting is ready. So you kind of chain them together through those promises. Our promise is kind of similar to the Java future, but the main difference is that the Java future is actually not asynchronous programming construct. It's a synchronization construct because .get blocks. Promise cannot be used for blocking. If you call .get on it and it's not ready, it will actually throw illegal state exception, not ready. So you have to actually just pass it as a parameter to appropriate operations. Also, I use the client. The question can arise where the client came from. So we can find it here in the generated code. And this app generated is just, it's generated by the Flow Framework annotation processor. So Java has support for annotation, so-called annotation processors. These are special components which look your code for presence of certain annotations. In this case, we are talking about workflow and activities annotation. And then it works our code, and our generator will generate the client for activities, for example. So we have GreeterOperations. It will create Greeter client, GreeterOperations client, and it's for every method defined in the activity, it will have a few overloads for that method. But the basic idea is the most important thing, that instead of just returning a string, it will return promise to string. And if you use command line build, you need to include end task, which will actually run before compiling your code to make sure that you generate those invoke annotation processor and it generates those client-side classes. Let's go back to the implementation of our code. So actually, just changing the operations to a client and changing the type of variables from strings to promises to string, we practically converted for implementation. It looks very similar to what we had, but right now our application is fully converted to the simple workflow. You can run it through simple workflow, and it will be absolutely durable. It will be fault tolerant. You still need to make sure that you will add logic which will, for example, retry operations if they fail, but at least the status of operation execution will never be lost, and you will be able to, or you also can, for example, create, invoke this operation even if your workers are not running. Let's review what we've done. We have a workflow interface which defines entry point when we start our workflow execution, and we have implementation of the workflow, which actually uses the generated client to invoke activities, and then we have activities interface added with activities and also some additional registration options, and implementation of activities is actually exactly the same as it would be in the synchronous case. we can count the number of lines, but you can see that probably we had to add a few lines of annotations and change some code just to return promises instead of real values. Certainly our conversion is not fully done because we have to create entry points, because this code is code, but we have to execute this code. So we actually have to create worker processes, which will pull simple workflow for activity and decision tasks and call it into the code we wrote. Greeter main worker. So we need to create activity worker, which is the class provided by the Flow Framework. And it takes 3 parameters. I'll describe them in a second. And then we need to register activity implementation, in this case, GreeterOperations implementation, and we need to start the worker. So we are practically done, besides we need to specify the parameters. The service parameter is actually the reference to the SDK client to simple workflow service, which and this, if we look at that, it actually provides operations which correspond directly to the operations exposed by the simple workflow web service. Most of them are visibility operations, so they're very useful when you want to query state of the workflows or get count tasks, count workflows, list, for example, closed workflow execution, list domains, list workflow types. And when we implement activities, the actually most important operation is pull activity task and respond activity task completed or respond activity task failed. But when you use Flow Framework, you actually don't need to deal with that directly, because Flow Framework actually provides all this functionality and embeds this functionality in the activity worker itself. So I cheated a little bit, and I have this config helper, which allows me to create the get the instance of AWS service, just to save a few keystrokes here. And then we have domain, and domain is just the way to partition your workflow executions and types into more than one bucket inside of the single AWS domain. So you can have multiple domains, like domain for organization, or domain for like one test domain and one prod domain, if you want to have them under a single AWS account. And it's kind of similar like S3 buckets, right? Because every object in every bucket is absolutely dependent from any other object. So helper, I have constant for that defined. And task list is actually, it's what activities are pulled from. It kind of has queue semantics. So when you schedule activity, always schedule to task list. And when you pull up for activity, always pull from task list. And it's kind of random. You name it any way you want. So let's call it webinar. So this is a complete worker implementation, which for our activities. Let's run it. Okay, it runs. If I don't have any login enabled, we don't see much here. But how do we know it actually ran? We can go and use AWS console. Provided by the simple workflow. So we have AWS tab here. And we have our webinar domain here. And we can see workflow types. We don't have any workflow types registered, but we have 3 activity types registered. And what happens is when we start the worker, first thing worker does, it actually registers activity types. And if you start a second time, it will try to register them again, but it will get already registered exception, safely ignore it. So it's pretty safe to start worker and try to register again. One thing to understand here is that as parameters we passed on the registration options, which in this case is timeouts, which we specified 5 minutes and 10 seconds, they are not they're not changeable. So if you specify registration options, then for example, you change them, it will try to register, but the type is already registered. You won't get these values changed. So you will need to the way to do that. You need to actually change the version of the activity implementations, or you can pass them when you actually invoke activity. So we know that our workers run. So let's do the same thing for the workflow worker. Actually, for brevity, I will just do it in the same process, but you certainly can run them separately. And workflow worker corresponds to the decider component in the simple workflow. And we use the same parameters. One thing to note here is that besides we use the same task list to call with the same name, task list for workflow workers, deciders, and activities are in different namespaces, so they don't really mix. I just use the same name here. But again, they won't see each other, activity tasks and workflow tasks. We need to register the workflow implementation, and the difference is that you have to register not the instance, but the implementation class. It has to do the way we reconstruct state for replay. I don't have time to cover it in this presentation. Please refer to the documentation. So, Greeter. And we need to start it. Obviously, in the real production environment, you probably will have some code which will actually shut down those workers cleanly. I just pass on it right now. So, and here's our workflow worker implementation. So if we kill this already running worker and rerun it again, and go back to console and list workflow types, we will see the workflow type registered, and it has the timeout which we specified. So one timeout which we didn't specify called task start to close timeout. This is very important timeout. It's the maximum time single decision can take. And usually single decision is milliseconds, so it's very short. So please don't specify it very kind of big value. I've seen people doing like hours or days, and that means that if single decision times out or fails for any reason, means that the workflow will not try to reschedule it for that amount of time. So the only thing which is left for us is actually the component which starts workflows. So I'll just copy the way we start workflows, again, we need to, instead of using Greeter directly, we need to use client. So we will use Greeter client external. And the reason we use it external, because there is Greeter client which is not external. And the difference is that a Greeter client external, I cannot really create that, because you have to use factory to create it. The reason we call it external because it's external to the workflow. So if you want to create a child workflow from inside of workflow logic, you will use Greeter client in Greeter client factory. But if you want to use client started from outside of workflow process, which is like any web server or client, like command line applications we are writing right now, then you will create it using external. So this is the whole code. All we do, we just get the factory, get the client, and then call greet. This will create new workflow instance. Actually, this call will go to the simple workflow and call start workflow instance. And other point here that, so let's run it. Other point is that you actually, what makes your application fault tolerant is that you don't actually even have, after types are registered, you don't have to have your workers running. So we don't have, I killed all workers, so we don't have them running, but workflow instance, create workflow execution. Okay, it executed. Let's do it second time. And if you go to the console, we will see two active workflow executions, and of type greet1, right? And if you look, we see all timeouts and parameters of that workflow execution, and also we can look at the events, which is history, of the workflow execution. So it has only two events. First is workflow execution started, and which contains all arguments of the workflow. As our workflow doesn't take any arguments, they are kind of serialized JSON format here with empty array of arguments. And then we see decision task schedule. What it means is that it waits for the decider to come up and make a decision, but as our worker is down, we don't see any, there is no any progress in the workflow. But you see that you could create instance, and it's independently of your workers being up, it's created and it's stored, and you can see its history. Let's bring up the workers. As we had two instances, we ended up printing hello world twice. Obviously, in real scenario, you practically always run more than one worker because for fault tolerance, and usually the most important thing is that decider workflow worker it's stateless because it makes decision, gets history, makes a decision using the logic you specified, and then discuss the state of your workflow. So don't think that there is any like thread or any resource on the worker which is waiting during the workflow execution. It can take very long time. The only thing which the only resource which is taken if your workflow is not active is actually resources inside of the simple workflow, the storage there. And also, if your activities are also usually stateless. So we have right now two workers running. Let's try to create new instance. What we call execution on the workflow. And let's look at the worker output. We saw that some of the activities execute on one worker and some of them execute on another worker. Let's look in the console. So we have this, we don't have active executions. Why? Because they completed. Oops, so we see that they completed. Let's look at them. So we see that first get name, then get greeting, then say activities executed. They completed. We see when they were scheduled, when they started, when they completed. And that is what activities view. Other view, which is very useful in troubleshooting, is events view, which is a pure history view. And it just represents every event in the history. We already saw the initially workflow execution started decision schedules, but when we brought up our workflow worker, it started the decision, and we actually can see the identity of that worker, which is PID and the machine name usually by default, and you have control over identity, so you can actually specify different identities for your workers. And you see when it started and who started it, then you see its completion, and then you see the result of the decision was that activity was scheduled. And we can see the argument input, and again, get name doesn't have any input, so it's empty array of arguments. And when we see the activity completion event, which provides the result, so we see result here. So and then we see a new decision, new activity execution, then again third activity execution. The last activity didn't return anything, but which was say activity. But it actually got input, which was hello world string. And then practically what I'm trying to convey here is that you see the full every step of your workflow, and it's very good for troubleshooting. Also, it's a very nice debugging tool because you actually can point your workflow code to this history, to the service, and replay in debugger as many times as you want the execution sequence of the way your workflow executed in production without affecting real production, because you just read history, replay it. So you actually, if you've got bug, you can reproduce it easily using the framework. Okay, going back to the our client. So one point I want to make. Okay, sorry, I switched to earlier. That workflow execution IDs here are just GUIDs. Why? Because you didn't provide any. How you provide the ID? you would just go and pass it here and get clients, right? Say ID 1. And let's kill workers and try to start workflow again. Okay, it started. Let's look at active executions, and we see execution ID 1. And then if we want to create ID 2, we will create ID 2. What happens if I try to create ID 2 again? We actually get the failure from the service, and the error code is workflow execution already started fault. What it means that you cannot have more than one workflow execution with the given ID active at the time. So it's hard guarantee provided by the service. And I want to reiterate a few times that simple workflow is a fully consistent service. We don't do any eventual consistency stuff. Every time decider sees history, it's absolutely fully consistent. We don't duplicate tasks. So if activity was scheduled, it will be scheduled at least mostly once. And then if it fails, failure will be delivered back to the workflow code, to the decider. But framework and the service never duplicate activities. So it's a fully consistent service. So let's go back and review, look at this slide, which shows what we actually have done. So we wanted to create this distributed and fault-tolerant hello world. How does it actually work? So the standard simple workflow architecture is that you have worker components which fall for tasks on a task list, for print hello and get name tasks, and then execute them and report results back, right? And we have decider component which falls for decision tasks and then provides the result of decisions back. So you wrote some more code using Java and pretty familiar Java constructs. And the framework, what Flow Framework does, is actually the workers, they implement the decider and the activity implementations, and which encapsulate all polling and dispatching logic. And that your workflow logic together with the framework code becomes a decider. And then your activity implementation plus activity worker code become the activity implementation. Why you really wanted to do such transition, like or write code using the simple workflow? For me, at least we've got a lot of teams inside of Amazon using the simple workflow. The main reason people I think use us, and its primary reason is because they want guarantees and they want a fault tolerance. And that simple application which I showed actually a pretty complex application because it's based on consistent storage, and we guarantee that things are executed only once. And as workers are stateless, it means that practically any worker can go down anytime. And simple workflow practically maintains the state of the workflow. So writing application, fault-tolerant application when your workers are stateless is trivial. That's why developers love it, because they can just focus on their business logic and make sure that their workers restart if they fail, and they don't need to do anything else really. And other reason to use simple workflow and flow framework is scalability. Because as it's a hosted AWS service, it was built to be very highly scalable, and it means that if your load goes up, it's our problem to provision enough hardware and make sure that we can support your load. So you really don't need to change anything in your application if you need to support higher traffic. And again, as your workers are stateless, so it means that from your point of view, scalability again is allocating just more workers, but you need to redesign anything because everybody knows that it's trivial to scale stateless applications. And also, as we are talking about activities can be very different. Some of them can be very heavyweight and can consume a lot of resources. So you actually can't scale every activity type or even kind of not even type, because you can actually have the same activity implementation, but for example, for different arguments, have different performance characteristics, but you can have different pools of workers for those. And also, I showed you a console that you have full control and visibility about your execution, right? So the orchestration logic code, the workflow code, gives you full control over your tasks. Because, for example, if you try to implement even the simple example I showed you using, for example, queues or database, it's like especially queues. If you ask you what's the state of current execution, okay, it's some message somewhere, and how do you find what's the current state? And if it's complex system, it can be 55 messages in different places backed up or being processed, and it's very hard to make sense what's going on in the system. With simple workflow, you always know exactly what's going on, and you have a full history of every event which happened. And also, the console goes through visibility API. I don't have any backdoor, so everything you can do in console, you can do through the API, service APIs. It means that you can integrate your own tools or command line utilities or dashboards through that API. So what AWS Flow Framework is? That most important point is that it just sits on top of a standard AWS simple workflow service API, and it allows you to write distributed applications using that. And you build decided activity workers, but again, all you need to think is about activities as operations, and you workflow code as just Java code, but asynchronous code. So you model your workflow definition as asynchronous program. And there are some technical reasons for this program to be asynchronous, like Java not supporting things like fibers. But at the same time, what we found that for a lot of workflows have very non-trivial workflow control paths. And it's actually easier to model them using promises and asynchronous computation than trying to model them as threads or as those control paths fit very well the asynchronous model. And also, it's most important when you write your code, you just write your business logic using standard Java constructs, plain old Java objects. You can have methods, fields. If you have practically everything you do in Java is allowable. There are some kind of minor limitations about external calls like non-blocking calls, and but you practically have full power in Java in your hands when you write your workflows. So let's go back and look. I mentioned a few times the activities client. What is actually, where it's coming from? Simple AWS Flow provides the annotation processor. It's standard Java annotation processor, which looks at annotation and uses standard Java mechanism to generate, to analyze the source code and then generates the client. So practically every time you put annotation, activities annotation on an interface, the framework code will automatically generate the client code. And the main difference is that it will just take the client code and change it to return promises instead of values, because all invocations are synchronous. It has more, a simplified version, it has more overloads, mostly around passing additional parameters like timeouts or task list into the activity invocation. And also it generates the same way it generates the client, external client, and client for the workflow. I can show it actually in Eclipse. What you do, if you go to the compiler, annotation processing, for any process which uses Flow has to have annotation processing enabled. And usually, by default, it has a directory name starting with dot. I usually remove this dot. And what it gives us, this makes this directory visible, and it has generated code here. So here's the client code for the workflow. We see 3 overrides. And okay, this one I'll describe a minute later, but basic idea that you can get additional start options. And these options, as we saw, it's this timeout. So this timeout can be passed when you start workflow instead of on registration. So what the promise is? So as I described, promise is like future like object, but in operations non-blocking. How do you wait for it? The way you wait for promise to become ready, you actually pass it as a parameter to the method, and this method should have asynchronous annotation. So the semantic is that as soon as method is marked as asynchronous, you call it, its body won't be executed immediately. It will return immediately. And but the body will be executed only when all parameters of type promise are ready. So it is safe to call get on it because if method is marked as asynchronous and parameters of type promise, as soon as this method is executed, all promises are guaranteed to be ready. So practically, this is the main construct you use if, inside the workflow code to wait for promises. Actually, other important point that this is a little bit different code than I specified in the sample is that here we don't pass name to the greeting. So what it means that activity get name is returned immediately. Then it means that get greeting is invoked immediately, and we actually will run both of these activities in parallel. And then greet will wait for both of them to complete. So practically, you have this kind of split join scenario if you use standard workflow terminology, but just implement it naturally through Java code. You run the two activities in parallel, then you have third one waiting on results of both of them. Other important part of the framework, and without it, it probably wouldn't be that useful, is error handling. Because as we have asynchronous computation going on, which has multiple things running in parallel, we have to deal with errors. And we cannot just rely on exceptions because exceptions in asynchronous code are not that really useful. And standard way to do that would be returning the error inside of the promises. So for example, Java does with future. The problem with that approach is that it actually has a lot of drawbacks, mainly around like it's like return code. It can be ignored, or it also it doesn't provide help with cancellation, because usually what happens is in this case, for example, we call this get name, get greeting, and greet, and for example, if get greeting fails, we really want to get name canceled, because it can be a long-running operation, and we know that we never will need it anymore. So what framework does, it provides TryCatchFinally construct, the class, and if, for example, any operation inside of do try fails, framework guarantees that it will cancel all other operations going inside of that construct, and only then deliver exception to the do-catch method, which itself can be pretty complex asynchronous computation. And only when it's done, it will call do finally. So there is much more to it. I recommend you going through Java doc of the TryCatchFinally class. It has pretty good description of all features of that class. Also, what's interesting that sometimes you can nest them. So TryCatchFinally can be nested inside of do try for another TryCatchFinally, and can end up being canceled itself. But even in that situation, we guarantee that do catch and do finally are executed. While you can practically write almost any error handling logic using TryCatchFinally, in a lot of cases you want a simpler solution. For example, if you want to make sure that if activity fails, for any reason times out or really fails, you want to retry it. So we provide out of the box a few annotations for expansion retry, one of them, that you can put in any asynchronous method, and it will retry that method call in case of failure according to the parameters. So just taking the expansion retry to get name would cause get name being retried as many times as specified, and this way you can make your application fault tolerant on, like, because there is fault tolerance of the keeping state of the application, but then if activity fails, you need to define your business logic, and this way you can make your business logic fault tolerant. This presentation is pretty short, so we don't have much time to cover everything, and I just want to mention a few other things which framework supports. So certainly it supports timers, so you can schedule activities or anything based on time. So you can create like distributed cron jobs, so practically any business process which requires some time handling is supported. We support signals naturally. which is the way you can identify workflow execution about some out-of-bound events. Certainly we support child workflows, kind of continuous workflows which reset themselves with the same ID. Manual completion activities are the way you practically disconnect activity from the activity thread. So practically you can have activity which again sends a mail to the user and then user replies, then it completes activity. It's also supported. Certainly workers have a lot of configuration options which allow to configure how activities are executed and how many polar threads, activity threads, rates. So there are a lot of options there. Certainly there are a lot of interesting troubleshooting techniques, how you troubleshoot workflows, what information is available through console, what available in the framework. One thing to look for is, I recommend going through documentation, is replay and what it says about determinism, because it actually puts certain restrictions of what you can do, you cannot do inside of the workflow code. Other interesting topic is how you actually route tasks to particular boxes or particular sets of work you're using task lists. We have integration with JUnit, so you can unit test any part of your workflow logic. And we have Spring integration, so you can actually create workflow objects and activities through Spring. So why do you want to use Flow? Just kind of to reiterate that. It's relatively easy to start. I showed you that it's not that hard to actually have fully working application in minutes. But at the same time, it's actually, our experience is that it actually has very good track record of scaling to really complex applications. Because you have full power of object-oriented design, so you actually can as soon as your problem becomes complex, you can actually redesign your application using all techniques and again deal with complexity. Also, error handling helps. Having the error handling which works in asynchronous case allows you to have very complex applications and still them being manageable. So other things that you can focus on business logic. We framework plus simple workflow let us deal with all complex problems of distributed systems, and then you just do your business logic. Obviously, your business logic will be distributed as well, so you need to deal with that. You need to make sure that you retry your activity executions or implement compensations using, for example, try-catch semantic. But again, the hard stuff is solved. You focus on your business logic, and also framework doesn't require you to implement any framework constraints, right? You code using plain old Java object patterns. Also, as the framework is pretty generic, using promises and Java code, you practically can implement easily any control flow workflow patterns. There is this patterns repository on the web of the workflow patterns, and there are some patterns which are pretty evolved, which most existing products just don't support. And for me, actually, it took longer to understand the pattern, what pattern wants from me, and what the use case, than actually to implement that when I try to prototype those. Other thing is that I showed you the way code is generated and that you use generated code, but you don't really have to do that. There are dynamic clients, so you can actually invoke activities by name and by version and by list of arguments explicitly. And this is pretty common when you, for example, want to implement a sort of domain-specific language on top of Flow. You can parse your config file and then wire your object graph accordingly using promises and then let it execute. So it's pretty straightforward to create like previous example, deployment example. I think in these samples we provide, and it shows how, for example, to do data-driven dependencies using Flow. Also, we wanted people not be very concerned about vendor lock-in, and so the library is open source. It's on GitHub. It's Apache 2 license. And again, as you write code using plain old Java objects, not to kind of any Amazon-specific API, you actually make sure that you can have your code not very dependent on the Amazon infrastructure if you really have that concern.
This is Balan Subramanian, the product manager, and we're going to cover some of the higher level questions first, and then we'll go back to some of the more programming questions which Max will handle. Some basic questions about whether this webinar will be available for later review. we will have a recording of the webinar available, and we'll post it on our YouTube channel. There will also be links to that posted in our forum. And then there were many questions about whether the framework is available only in Java, and what about .NET, Ruby, Python, and Perl. Currently, the framework is available only in Java. We are working on making it available in other languages as well. The related question was, what about non-Java development? So the Flow framework, of course, lets you use all the features of SWF, but you can also use SWF in other languages just using the various SDKs that we provide. So we have SDKs for PHP, Ruby, .NET, and Python. You can use all SWF features using those SDKs. And then there was a question about whether SWF is based on some third-party tools. If you're asking about the Flow framework, some of the dependencies, yes, there are some dependencies on other libraries. The code is available for the Flow framework on GitHub. It's open source, so you can download it and look at it, and we encourage you to contribute it to it as well. As for SWF itself, it's a service that we manage and run, and it was built by Amazon. And then there was questions about whether SWF provides a graphical tool like other BPM tools. So in our experience, what we have found is that when people are doing BPM, they use the tools for the modeling, but then there's also the implementation aspect of it, which is often the more difficult thing to do. So what SWF provides is the foundational technologies for you to implement your workflows and any other business applications or distributed applications. And it's very easy to do mappings between like BPMN and BPMN and XPDL to the Flow framework or to the service APIs. And we see some of our customers doing that already. So we do not provide a graphical tool, but more importantly, we provide the very strong foundation that is scalable and reliable for your business processes and distributed applications. And then there was a question about whether there are any presentations about SWF itself. If you go to our detail page, you will find a lot of material. You will also find a link to our previous webinar called Introduction to Amazon SWF that just talks about SWF and not the Flow framework. And if there are any specific questions that you have about SWF, we encourage you to use our forums to post your questions, and we monitor them continuously. And then there was a question about whether all the code executes in the cloud and what computing power is used for that. So the workers and the deciders, you have complete freedom on where you run them. So you can run them on the Amazon cloud, you can run them in your private data center, and you can choose which computing resource should be used to support your workers and deciders. And a related question to that was, how are external workers supported? External workers, all the components, workers and deciders, pull SWF, and we use a mechanism called long polling, which is more efficient. So you can run your workers anywhere you want. They don't have to be on the Amazon cloud, but since they're just polling SWF, you don't have to worry about any firewall issues and such. So that's how we support external workers. Now we'll switch back to Max.
So the question is, what are the valid types of T for promise T? So practically a generic parameter. Framework by default uses Jackson to serialize arguments. So anything that Jackson can serialize by and you can pass as argument to activity or return from activity. But when you use promise inside of the workflow code, it actually can be of any type. So because if it doesn't cross the boundary, the serialization boundary, there is no any actually restriction. It's just Java object and can be of any Java type. It can be hash map, it can be anything, it can be other promise, which probably not very useful construct. But very common construct would be, for example, promise of list of other promises. Also, as I mentioned, serialization, it's pluggable, so you can plug in your own mechanism to convert Java objects to like string format or back. And so if you don't like Jackson, if, for example, want to do XML, or, for example, you want to do XPD, the XML, like any other format, you can do it. It's especially useful if, for example, you want to implement your activity workers in other languages. Question was, do you want to use separate task lists for test prod, or you want to use separate AWS accounts entirely? I think they're good. If you can use separate AWS accounts, I would recommend it for test prod, just because there are so many things you can do in test which would screw up your for prod, that if you can do different accounts, I would do it. If you cannot, I would recommend using domains for test prod. Task lists are mostly to route activities and workflow workers across multiple kind of business units or like different business use cases. Question is, what happens if the execution timeout is exceeded? Is an exception thrown? If activity execution timeout is exceeded, yes, the into the event is inserted in the history, and from the workflow point of view, it looks like the call to the activity failed with an exception. And we have different exceptions for different type of failures. So for the, you actually know what type of timeout happened. For example, if it's scheduled to start timeout or start to complete timeout, so it will be part of the exception information. The question was, how can we execute many activities after step one? Say get name. I want to schedule many get greetings as a broadcast. I could show it in Eclipse, but basic idea what you would do is it's non-blocking code. You will just call get name from a loop. So you can imagine doing for e equals like to 100, and then just call get name, and then you put results in, into the list, so a list of promises, and actually you can wait on the list of promises to every promise in the list become ready. Using asynchronous method. So yes, you can do broadcast and you can join that broadcast. The question is, where did the GreeterOperations client implementation came from? It was automatically generated by the annotation processor, which was installed, configured with my project in the Eclipse. So practically you have to, if you do command line build, you need to have end task which will invoke annotation processor, which will generate this client-side code. Question, is there a max size for the input? Yes, a service puts a restriction on the input of activities 32,000 characters, and it means that arguments in serialized form should be less. So the usual practice is that if you feel that the object can become large, you just store them, use for them something like S3 to put them aside, and you just pass references through the workflow logic. Question, how long will a workflow wait if no workers are running? Is that controlled by at all by the timeout in the workflow registration options? Correct. Workflow registration options, the timeout which we specified was exactly that it's workflow lifetime time, workflow start to close timeout. I remember exact name of it, but it says how long workflow can exist, and if nothing happened, you just created it and no decider is running, at the end it will fail, and it will be automatically closed by the system. Can you scale the workers using CloudFormation?
It's not something we do automatically because we give you complete freedom on how you do that. For example, the sample that we have in the console that actually uses a CloudFormation template to spin up the workers that are required for that sample. So that is definitely possible.
Can you show how to cancel long-running workflow programmatically for a manual action? I don't have time right now, but the Amazon Simple Workflow client has request workflow cancel operation, and it's already integrated with the Flow Framework. So if you call that operation on passing workflow instance ID, the cancellation request will be received, and the workflow will perform a clean shutdown. By that I mean that all catch and finally blocks will be executed of all try-catch finally classes. How do I change timeout and dynamic timeouts? So if the only registration options are not editable right now, so practically the only way to change them would be registering a new version of the activity type or workflow type. But when you pass them as options to the when you call activity client, those are per request. So every time you call activity or start workflow, you can specify different timeouts, and they will be using timeouts which you specified, not timeouts provided by on registration. Can I schedule tasks with a delay? You cannot schedule tasks with delay. You can create timer, and then when timer fires, you can schedule a task. So you can get what you want by delaying the execution of a task, but the way you do that is you have to program it through timer. Can I start workflow first and workers later? Yes, I think I showed that. The only requirement is that your workflow types and activity types should be registered. And again, you can register them using some script or through console, or standard ways to run workers at least once to register types, and then you can shut down workers and start as many workflows as you want, and they will be in the system until they time out.
We're at the end of our time, but we're going to keep going with some more questions. So feel free to hang on and listen to some more of the questions.
The question is how to use external systems in the workflow or additional dependencies. And the basic idea that you will wrap them in activities. And so your activity code will call into the external system. And then return results. And then your workflow will just invoke those activities. And again, activity can be implemented in any language. It can. I showed you Java version, but it doesn't need to be a Java, or Java can just initiate that, and other language can complete the activity. So the way you do that, you integrate in these activities. Question is, are exceptions viewable only through Amazon panel, through the console? No, they're actually thrown into the workflow. They're real exceptions. And I didn't have time to show that. This is, I think, the cool thing about the way exceptions are done in the flow is that it actually provides you real stack trace, which represents you the way your code was executed. Even if it's was asynchronously executed, you actually will see the stack trace, which is really friendly. So yes, you will catch those exceptions. You can log them, and you can, for example, send them to activities to execute. But yeah, but panel is just a console is a nice way, especially when you do development. How do you program decisions explicitly? Do I code the decider? You actually don't program them explicitly. You write your workflow code. So I actually programmed the decider when I wrote the workflow implementation, which was the Greeter implementation. The Greeter implementation was the decider. So this workflow code is the decider. This is the most important thing about Flow, that you write your decider as an asynchronous program, and that code becomes a decider. Certainly, you need to configure it is the workflow worker. So when you get workflow worker, attach code to it, it becomes a decider. And it's also very important thing that this code actually, the way it executes, is actually executes decision tasks, so it doesn't keep state between those tasks.
Okay, and then there were some questions about pricing itself. The pricing is, of course, fully explained in our detail page, but just to give you an overview of the pricing, for SWF itself, it's a pay-as-you-go model. So we charge by the number of workflow executions you run, the number of different activities or tasks that you perform in the execution of each workflow, and also for how long the workflow execution is executing. The first 24 hours that a workflow execution is running is free. There are no charges for that. But after that, there are some very small charges, like 5 cents for 10,000 workflow executions. If you choose to retain your workflows after they complete execution, you're charged at the same rate that I just mentioned. There are no charges for actually registering workflows. So if you register some workflows and workflow types and activity types, and you don't run any workflow executions, there are no charges. Then there was another question about whether activity implementations execute based on the state of the workflow. So just to explain that, the activity implementations themselves can be stateless in the sense they don't need to know about the overall state of the application. The decider tells the workers what to do next, or it tells which task should be scheduled next based on the state of the workflow, which is maintained by SWF. And then there was just a general question about whether there will be a follow-up webinar with advanced concepts. Yeah, we'll definitely do one. We have plans to do webinars both on the service itself, on Amazon SWF itself, and based on some feedback, we'll focus that on the various use cases and provide more examples of using the service. And we will have a advanced concepts webinar for the Flow framework. There are many features that Max didn't have time to go over today, and we'll definitely cover those in the next webinar. And that's all we have for today. Thanks very much for joining. As I mentioned earlier, a recording of this webinar will be available. And any more questions, please post them on the forum, and we'll make sure we answer them there.